Hi viewers, welcome back to our YouTube channel SHOBHAN'S Maths Corner. Through this platform, I've been explaining all the maths concepts up to 12th standard and also the useful information for all competitive exams and other state level and national level exams. So now, through this video, I'm going to explain set theory part 2. Part 1 already we did in other video that I will share you in the description. Now in this video, let us discuss the second part of the set theory. So before starting the concept, once again I request all of you to subscribe my channel and share with your friends to whom it is helpful. Okay, let us start the concept. Set theory. So this is part 2. In part 1 we have already discussed the definition, what is a set and the types of sets and how to represent the sets like builder form, roster form, everything we have discussed in that. Now in this video, let us discuss the operations on sets. What are these operations? Generally, in arithmetic, the operations, we know the basic operations like addition, subtraction, multiplication and division. More operations are there, but these four operations are basic operations. Okay. In the same way, in sets also we have operations. Okay, let us see what are the operations. Union of sets, intersection of sets, and difference of sets, and complement of a set. So this complement is the little related to a difference of sets only. So these are the four operations: union, intersection, difference, and the complement also. This is linked with the difference only. So let us discuss the operations one by one. First, union of sets. If you take two sets like A is equal to 1, 2, 3 and we have B is equal to some 4, 6, 8 like this, there are two sets A and B. Now A union B, union is denoted by this U, letter U, union, A union B. A union B means we combine the elements of A and B and put together in the same set. So here if you write all together 1, 2, 3, 4, 6 and 8. This is the A union B. If you combine elements of A and B, this is A union B. So in case, suppose if there is some common element, then what shall we do? Suppose this is A is equal to 1, 2, 3 and we have B is equal to some 2, 4, 6. Now while writing A union B, we write 1, 2, 3, then 4 and 6. Because in the beginning of the set theory we have discussed elements should not be repeated in the sets. So in A union B, 2 is here and here, but while combining them, we should not repeat them. So the order can be any way. Okay, you don't consider the order. You may write 1, 2, 3, 4, 6 or 2, 1, 4, 2, 3. Any way order you can write, but elements should not be repeated. So this is the union of sets. Union means combining. Now the general form of the union, like a builder form. Suppose A is a set and B is a set. Then how do you write the builder form? X such that X belongs to A or X belongs to B. You see carefully here we are using the word or. Means the element may be belongs to either A or B. Can be taken from anyone. So this word, see carefully, or. Either from A or from B. We can pick the elements. We put all together, that is A union B. Now let us see intersection. So intersection of two sets. So we use the symbol like the reverse of U. This is intersection. Let us see one example. A is equal to some 1, 2, 3, 4, 5 and B is equal to 2, 4, 6, 8. These are the two given sets. Now let us write A intersection B. A intersection B means we will pick the common elements which are common in A and B. That is the intersection. Here you can see 2 is here and 4, 4. That's it. So 2 comma 4. So this is the intersection of A and B. Intersection means we will take the common elements, the elements which are there in A and B. Therein we use the word R here and. So 2 belongs to A and B. 4 belongs to A and B. That's why we write the builder form as A intersection B is equal to X such that X belongs to A and, here we use the word and, X belongs to B. Whereas in that union we used the word R. Here we are using and. See this carefully, and in the sense the element belongs to both A and B. In union the element belongs to either A or B. So this is about the intersection. Now something special about the intersection. Let us see. Suppose there are two sets. So A is a set of like even numbers 2, 4, 6, 8 and B is equal to set of odd numbers 1, 3, 5, 7, 9 less than 10. The odd numbers and even numbers we are taking less than 10. So now let us try to write A intersection B. So now tell what are the elements in A and B. 2 not there, 4 not there, 6, 8. So no, not possible because these are even numbers, those are odd numbers. There is no common number for these two. In such case nothing is there. This is what is this? This is empty set. What is empty set? If no element is there, that is empty set. We discussed in the first part, empty set. So like this, if there are two sets in which there is no common element, such sets are called disjoint sets. What are those sets? Disjoint. Disjoint means there is nothing common. If A intersection B is equal to 5, then A and B are called disjoint sets. Disjoint set means there is nothing in common. Okay. So this is about the intersection. Next, difference. Third one is difference. Like in arithmetic operations we use subtraction. This is also similar but not same. Let us see how. Suppose A is a set in which we have 1, 2, 3, 4, 5, 6 like that. There are some elements. And in B we have like 2, 4, 6, 8, 10. Some elements are there. Now let us find the difference of A and B. Difference of A and B, we use the symbol minus only. A minus B. Now see carefully. We are A minus B. So here we are taking the elements of A which are not there in B. Means so 2, 2 common. We should remove it. 4, 4 common. 6, 6 common. So these are the common elements. Now the elements left in A are 1, 5 and 7. This is A minus B. See carefully, to find A minus B, take the elements of A only which are not there in B. Means the common element should be removed. On the remaining elements of A, if you write, that is A minus B. Now let us see B minus A also. So we need to write separately. From B, we will pick the elements which are not there in A. So already we cancelled the elements which are in common. If you write the remaining elements of B, this is B minus A. Clear? A minus B means the elements of A which are not the elements of B. So after cutting the common elements, the remaining elements of A, if you write, that is A minus B. So here also, if you cut the common elements, the remaining elements of B, if you write, that is a B minus A. So this is A minus B, this is a B minus A. This is about the difference. Now, complement of a set. So this complement of a set, this is usually we write dash, A dash. So A dash n is equal to U minus A. What is this U? U is the universal set that we discussed in the first part. So what is universal set? The universal set is a set which contains all the elements related to that particular context. If you are dealing with some particular issue, the elements belongs to that, related to that issue, the all elements, if it has, that is a universal set. Suppose you are dealing with a question related to the students of a school, like different classes. Set A is some 10th class, B is 11th class, like that you can take, and C is the cricket team, D is some other team, like that. If you take different ships, all these elements are belongs to the whole school, then your school whole children, that is a universal set. So that depends on the situation what we are taking, that particular context. So here, so let us say this U is the universal set, that is a school, and A is a set of class 10. Then A complement is equal to U minus A. So from universal set, from the school, if you remove this A, here we are taking some 10th class, then we left with the remaining element, that is remaining school other than A. So all the elements other than A, that is the A complement. Similarly, any elements, so B dash means U minus B, like that we can take. Now, what about U dash? U dash means we are taking U minus U, then nothing is left. U dash is equal to what? 5, because we are as per the definition, we should subtract the set from U, but already this is U, so U minus U is equal to 5. So U dash is equal to 5. And what about 5 dash? 5 dash means U minus 5. See, from U, if you subtract 5, nothing is subtracting, so you left with U only. So now 5 dash is equal to mu, mu dash is equal to 5. These two are important, you should remember. Now, let us see one interesting thing. A dash whole dash, we said it's complement also, A complement whole complement. So what do you get if you see first A dash means we did U minus A. U minus A means what? Universal set without A. Now again if you subtract this A dash from U, then again you will get back A itself. See carefully, A complement whole complement is equal to A. First A dash is equal to U minus A. So again if you subtract that A dash from U, you will get back A only. So if you take any set, complement and whole complement give the same set. This is the complement. Okay, and two more important things we'll see. A union B whole complement is equal to A complement intersection B complement, and A intersection B whole complement is equal to A complement union B complement. These two are called DMorgan laws. These are very important. These are called DMorgan laws or DMorgan properties. A union B whole complement gives us A dash intersection B dash. Here it is union, intersection will come. A intersection B whole dash is equal to A dash union B dash. These are called DMorgan laws. Okay. Now let us see the properties of this union intersection. See, A union B is equal to B union A. Means whatever the order you may take and combine A and B, the result remains same. This is a commutative law. You know, this is a commutative law. So same law is applicable in intersection also. A intersection B or B intersection A. Whatever the order you may take, the result remains same because the common elements remain same. So A intersection B is equal to B intersection A. But if you come to this, A minus B never be equal to B minus A. These two are not equal. The difference are not equal. So these union and intersection both are commutative, but difference is not commutative. So you can't commute, they never be equal. Similarly, we can check for the associativity. You know associative law? A union B union C is equal to A union B union C. See here, we are associating B and C in the left side, then with A. In the right side, we are finding A union B union C. First we are associating A and B. A union B union C. So this is true. So in union of sets, associative law is applicable. That is true. Now, if you take intersection A intersection B intersection C and A intersection B intersection C, so here this is also equal. Means in intersection also associative law obeys. Means here we are associating B and C while intersecting, then with A. On the right side, first we associated A and B, then with C. A intersection B intersection C is equal to A intersection B intersection C. So this is applicable. Okay. Now for the difference, we have more laws and properties for this also, so that we will go in depth to the subject in the other video, because it is very lengthy topic. We should discuss in detail each and every topic for each and one, like union, separate video, intersection, then difference. So all these we should discuss separately, because for the higher classes, for higher competitive exams, those concepts are needed, that we shall discuss. Okay, that we will do definitely. So some particular topics also which are like important or little complex, such questions also I will explain separately. So now before concluding this video, now let us see Venn diagrams. Actually, these Venn diagrams is a very important topic in maths. Not only in sets, actually we use in set theory and probability. Not only in this reasoning also we use that. So what are these Venn diagrams? So these Venn diagrams, we use the rectangles, squares, circles and ellipse. You can use any of these figures to represent some data. Let us see how. Suppose triangle, it represents the doctors, okay, and square represents the engineers. These are the doctors, this is the engineers. Now there is another one, let us say circle, here some teaching professionals. Now this is a ellipse, this is the political leaders. This is for doctors, this is for engineers, this is for teachers. Now these are politicians. So these political leaders. Now suppose if you are given some here 2, here some 6, here 5, like that, if you are given the numbers, that we can explain what is the result. So now if you see, how many doctors are politicians? They can ask like this question, how many doctors are politicians? So we can see the common thing, doctors and politicians, that is 2. Okay, how many teachers are politicians? This is the politicians and teacher, this is 5. How many politicians are like alone? They are not doctors, not teachers, not engineers. Only one politician does not belong to any of these. How many doctors are only doctors? They are not politicians, only 4. So like this, they can ask us any type of typical question. First we should analyze. So what is given and which figure represents what, that is very important. And we should go through the data to answer this. So how this this is the, like in logical reasoning and all these are helpful. How it is helpful in sets, let us see. Suppose as we discussed earlier, A is equal to 1, 2, 3, 4 and B is equal to some 2, 4, 6, 8, this is given. Now I am taking 2 circles, one is for A and another is for B. This is A, this is B. Now if you see 2 and 4, these are there in this and this, and 1, 3 here and here, 2, 4 and 6 and 8. Okay, so if by this single picture we can describe what is union, what is there in union, what is there in intersection, what is there in difference, everything. Let us see how. A union B means directly you can say 1, 2, 3, 4, 6, 8. That gives the union, because just pick all the elements. Because we wrote 2, 4 in the common area, means which is in the intersection. So no need to write repeatedly. So directly if you pick all the elements which are there displayed here, 1, 2, 3, 4, 6, 8, that is A union B. Suppose if they ask us to find only intersection B, just you can pick the thing which is in common, 2 and 4. 2 and 4. Now what is a minus b? Just 1 3 is in a minus b and 6 comma 8 is in b minus a. Like this, the Venn diagrams are very useful to explain the concepts of the sets and to solve some questions also. This is very useful. Now without numbers also we can describe the sets like A union B, just without any number. So if you fill the whole thing, this is A union B, that is A union B. Now A intersection B, A intersection B, if you want, just fill this here. This A shaded area gives us A intersection B. Now what is A minus B? Just we shade the area only A, which is not common. This gives us A minus B, A minus B. And if you fill only this side, that is B minus A. Then what about A complement? This is also important. Suppose if you take the rectangle as a universal set U and this is A. Now A complement means other than A. The whole thing is filled. This is A complement or A dash. This is A. The remaining, this whole thing is U. So now the shaded region is A complement or A dash. Like that, we can describe the sets very easily, and some questions also we can solve very easily by using the Venn diagram sometimes in place of using the formulas and all. This is a very easy way to find the solution. Okay. Now based on these sets, we have already discussed about the cardinal number. So by using the cardinal number, we can find the relation between union, intersection, and finding A and B. So this is also operation, but that is a little advanced. That definitely we will discuss in another video. So okay na? So I hope you understood the concept what we discussed today. Once again, let me conclude all the things what we have discussed here. We have discussed the operations of sets, union of sets, intersection of sets, difference, and the complement. So here union means if you combine the elements of both the sets and write together, that is the union of the sets. Here in sets, elements should not be repeated, so that's why even if there is something common in both, while combining them, we write the elements only once. That is the union of sets. And intersection means we take only the common thing which are common in both. So A intersection B or B intersection C, whatever. About intersection, one important we have discussed important thing, that is if two sets have no common elements, but that is A intersection B is equal to 5, then A and B are called disjoint sets. Disjoint sets, that is A intersection B is equal to 5. Now difference means if you subtract A minus B means we write the elements of only A which are not common, that is A minus B. Similarly we can find B minus A also. After that, about the complement, any set complement is equal to the difference of U as universal set and the set, that is A dash means U minus A, and A dash whole dash is equal to A. So these are the topics we have discussed. On that again we have discussed the commutative law, associative law, and about that DMorgan laws. That is also very important. All these we have discussed. Actually this is a very big concept, not that difficult but very important, because it is linked with all the topics of the mathematics. Not only that, in reasoning or competitive exam reasonings also they used to ask such questions. That's why this is very important. So follow my videos. In the next video, definitely I will explain some important questions which were asked previously in the competitive exams and other exams. So follow my videos, subscribe my channel, keep in touch. Bye.